Hi everyone, hope you're doing well today. This video is going to finish out our crash course on logic by talking about necessary and sufficient conditions and how they relate to trying to give clear, precise definitions and the role that they play in a method that comes from philosophy that's known as conceptual analysis. So in this video we'll talk about necessary conditions, sufficient conditions, how these play a role in giving definitions, the idea of a counterexample and how that can help us assess proposed definitions, and how all of these ideas play a role in this method that I called conceptual analysis. So an example I wanted to start out by considering, just to introduce the topic, is imagine that you're in a situation where you've enrolled in an academic course where you'll get a letter grade at the end of that course, and for several practical reasons you care about which grade you get. A problem arises though because at the beginning of the semester you realize, well, how do I get the grade that I want? Well, it depends upon what's involved in getting that grade, and different institutions, different professors, and different classes might have different kinds of grading structures and policies. And so your goal at the beginning of the class might be to first figure out and get clear about what those grades mean in this particular class so you can plan accordingly your strategy for what you might have to do to try to earn the grade that you want. And so the solution for trying to go from being confused about, well, which kind of structures does this particular class use, to a clear understanding of what these grades mean is you might start looking closely at the syllabus or ask the professor various questions to clarify what these grades mean in this class. And the kinds of questions you might ask are things like, well, what's the cutoff for each grade? Is it 90% overall? Are pluses and minus grades used? What assignments are used to calculate that overall grade? And how much of the grade is determined by each assignment? You might ask things like, well, what's the penalty for cheating? Would that result in an F on that particular assignment? Or could it result in an F in the entire course? And when you ask these kind of questions, when you try to gather this kind of information, what you might not realize is that you're trying to clarify the idea of what these grades mean by learning about what is necessary or sufficient for various grades. So let's talk about necessary conditions. Well, to say that A is necessary for B is to say that you must have A to have B. You can't have B without A. And putting this in terms of what's called a conditional statement, an if-then, well, if you don't meet the condition of A, then you don't meet condition B. So those are all the same way of saying that one thing's necessary for another. An example here is, in this course, completing some assignments is necessary for passing, because you must complete some assignments to pass. And you can't pass without turning in any assignments. And if you don't turn in any assignments, then you won't pass. Now, on the other side here, we have sufficient conditions. To say that A is sufficient for B means that, well, having A is already guaranteeing that you have B, or A by itself is already enough for B, or if you have A, well, then you have B. Now, all those are different ways of saying that one thing is sufficient for another, and an example of this is in this class, well, getting a 95% on every assignment would be sufficient for getting an A in this class when you look at the syllabus, the way things are set up. So getting 95% on all your assignments would guarantee that you get an A. Getting 95% on all your assignments, well, that would be enough to get an A. And if you get 95% on all your assignments, then you would get an A. I want you to try some practice cases. Is having 4 sides necessary for something to be a square? The answer here is yes. This is because if something does not have 4 sides, then it's not a square. Something must have 4 sides to be a square. That is necessary. Now another question. Now another practice case. Is having 4 sides sufficient for something being a square? Here the answer is no. And this is because the fact that something has 4 sides does not guarantee that it's a square. So that's not sufficient. Now we can see that by considering this example of this shape here. Well, this rectangle, notice it has 4 sides, but it's not a square. And so that shows that having 4 sides is not enough, is not sufficient, doesn't guarantee that it's a square. This is what's known as a counterexample. We'll talk about these a bit later in the video. Let's consider some more practice. Is getting 100% in this class, is that necessary for getting an A? Here the answer is no. And that's because to say that this is necessary, if it was necessary, well, that would mean that if you don't get 100%, then you don't get an A. But that conditional statement is wrong because there are other ways to get an A besides getting 100%. If you look at the syllabus, well, the range of grades that will get you an A is 90% to 100%. So you don't need to get 100%. Consider the following: someone who gets 95 overall. Well, that student would not get 100%, but they would still get an A. Is getting 100% overall in this class sufficient for getting an A? Well, here the answer is yes. If someone gets 100% overall, then they get an A. That guarantees that they get an A. One thing I want you to be aware of is a common mistake that students make. Sometimes students think that necessary and sufficient conditions are contrary ideas. So they think that if one thing is necessary for another, well, then it's not sufficient. Or they think that if one thing is sufficient for another, then it's thereby not necessary. That is a mistake. Sometimes that might be the case, but not always. These ideas can come in any of the following combinations. Sometimes a condition A will be both necessary and sufficient for B. Sometimes it'll be necessary but not sufficient. Sometimes it'll be sufficient but not necessary. And sometimes it'll be neither necessary nor sufficient. Getting at least 90% overall in this course is both necessary for getting an A because, well, you need to get at least 90%. If you get lower than that, you won't get an A. But it's also sufficient because if you do get at least 90%, well, that's enough to guarantee that you get an A. Having a child is necessary and sufficient for being a parent. To be a parent, you must have a child. Moreover, if you do have a child, well, that's enough to guarantee that you're a parent. Similarly, a math example: being divisible by 2 is necessary and sufficient for being an even number. So you need to be divisible by 2 to be an even. If something is divisible by 2, well, that's enough to guarantee that it's an even number. Let's consider some examples of necessary but not sufficient. Taking the final exam is necessary for passing this final exam, but it's not sufficient. So if you don't take the final, you're not going to pass it. But taking the final doesn't guarantee that you will pass it. You could still fail. Living in the United States is necessary for living in Alabama, but it's not sufficient. Because you could live in the United States, but live somewhere else, in a different state like New York or Illinois, Alaska. Being a mammal is necessary for being a human, all right, but it's not sufficient. Something could be a mammal without being a human. All right. Something could be sufficient but not necessary. Getting an A on every assignment in this class is sufficient for passing, but it's not necessary. If someone gets an A on every single assignment, that does guarantee that they will pass. But you don't need to get an A on every single assignment in order to pass. In fact, you could get a C on every single assignment and still pass the class. Similarly, being a square is sufficient for being a rectangle because if something's a square, that thereby guarantees that it's also a rectangle, but it's not necessary. Something could be a rectangle without being a square. Teaching math at high school is sufficient for being a teacher, all right? That guarantees that you're a teacher, but it's not necessary. You could be a teacher in some other subject, for instance. Now lastly, here's some examples where something is neither necessary nor sufficient. So completing all the assignments in this course, they're neither necessary for passing. You could skip one discussion board and still pass the course, so it's not necessary to complete every single assignment, but it's also not sufficient. Someone might complete every single assignment in the course and fail every single assignment in the course. And so merely completing the assignments is not sufficient. It doesn't guarantee that you pass. Similarly, voting is neither necessary nor sufficient for your preferred candidate winning. You might go out and vote and the other person might still win because more people voted for the other person. Or you might stay home and not vote and the person you wanted to win still wins because, well, the other people voted for them. Similarly, being a billionaire is neither necessary nor sufficient for being happy. You don't need to be a billionaire to be happy. There's lots of people who are not billionaires that still live very happy lives. Moreover, being a billionaire doesn't guarantee that you're going to live a happy life. You could be a billionaire and still be completely miserable and depressed. So now I want to say a little bit about how these ideas of necessary and sufficient conditions can be important for thinking about various topics. All right, so when we think about the world, when we think about various topics, we use various ideas and concepts and we engage in arguments that use those ideas and arguments to try to learn new things, to come to new conclusions. But if the ideas or terms or concepts that we're using in our arguments to come to various conclusions about how things work or how things are, well, if those ideas are unclear, then they might lead us to making mistakes in our reasoning and come to conclusions that aren't correct. This is analogous to how if you might investigate biology or investigate the solar system, you want to make sure that your tools are precise and give a clear picture of the world. If you use a microscope but it's fuzzy and imprecise, well, you might end up making mistakes because of that unclarity in the tool. Similarly, if our ideas, if these tools we use to think about the world, if those are unclear, then our thinking, our reasoning, and our arguments might lead us to make mistakes in the conclusions we draw. So sometimes we can try to check whether an idea we have is clearly understood by trying to give a definition of it. Now, ideally, a definition would give us a list of conditions where every condition on that list is necessary for the idea you're defining. So you don't want to include any unnecessary information in your definition, any extraneous information. But moreover, you want to make sure that the information there is enough to define it. You want to make sure that when you take all the things in the list together, they are sufficient for the idea you're defining. You don't want to be missing anything from your definition. So here's an example. We can define the idea of a square as a plane figure with 4 equal sides and 4 90-degree angles. So notice there are various conditions specified in this definition. A square is something that is a plane figure, two-dimensional figure, something that has 4 equal sides, and something that has 4 90-degree angles. So we've tried to define the idea of a square as something that meets all 3 of these conditions. Now notice, this seems to meet that criteria of an ideal definition. Each of these things are necessary. So being a plane figure is necessary for being a square. Having 4 equal sides is necessary. Having 4 90-degree angles is necessary. Moreover, when we take all 3 of these together, so not by themselves, but when you take them together, they are enough. They are sufficient for something being a square. If something meets all 3 of these, that thereby guarantees that it is a square. Now, creating an ideal definition, however, can be difficult. Sometimes we might try to define a concept, but fall short of that ideal without realizing it. And so a proposed definition that we come up with might end up being too broad. It might include too much. So imagine you try to define a sandwich as food you eat for lunch. Well, that definition includes too much. Since people eat mac and cheese for lunch, that definition would wrongly classify mac and cheese as a sandwich. And so this happens when the conditions specified in your definition are not actually sufficient. The fact that something is a food you eat for lunch, that is not sufficient for it being a sandwich, and that's why this definition is too broad. But a proposed definition could also be too narrow. It could leave some things out. So imagine you try to define a sandwich as, well, 2 pieces of bread with meat in the middle. Well, this is too specific. It's too narrow because it doesn't include enough. It has left some things out that qualify as sandwiches. For instance, a grilled cheese doesn't have any meat between the 2 slices of bread, and so this definition would incorrectly imply that a grilled cheese isn't a sandwich. But we all know that grilled cheese sandwiches are in fact sandwiches. And so this kind of mistake happens when the definition you try to give includes conditions that aren't actually necessary. Having meat between the 2 slices of bread is not actually necessary for something being a sandwich. Because we can make these mistakes when we try to define certain ideas or concepts, well, we might want to show someone that they've made a mistake, or we might want to try to discover our own mistakes. Now, you can do this by trying to show that something in that definition is not necessary, or by showing that the conditions aren't actually sufficient. And a counterexample method is one way to do this. Imagine someone says that A is necessary for B, but you want to show that they're wrong. You want to show that this isn't actually necessary. What you would need to do is you would need to give an example where you have B without A. You thereby show that A isn't necessary for B. On the other side, imagine someone says that A is sufficient for B, but you want to show that they are mistaken. Well, to give a counterexample to sufficiency, you want to give an example where that A is present without the B, thereby proving that A isn't enough, doesn't guarantee that you have B. So now let's try this out ourselves and try to come up with counterexamples. Imagine you and your friend are trying to create a definition of a bachelor. Now, this isn't a very interesting concept, but we want to start with the toy concepts before we move to more abstract, difficult concepts. Imagine your friend makes the following suggestion. They say, let's just define a bachelor as an unmarried male human being. This is not a good definition of a bachelor. Can you think of why this is a bad definition? One reason it's a bad definition is because I can give a counterexample to it. Malcolm is a 2-year-old human being that is male and unmarried. So notice Malcolm meets this proposed definition, but intuitively we would say that Malcolm is not really a bachelor. And so this shows that meeting those conditions in your friend's proposed definition are not actually sufficient. Now, when you think about why Malcolm, this example, doesn't qualify as a bachelor, that might help us try to figure out how to improve our definition. And so your friend might then try to make a revision and say, okay, I just need to add some more conditions to make them actually sufficient for being a bachelor. And so maybe a bachelor is an adult male human being who is unmarried. Now, this is certainly an improvement, and so we've gotten a little bit more clear about the concept of a bachelor, but I want you to think, could you think of any additional problems? I'm not going to spend too much time going over I'm not going to spend too much time giving more and more counterexamples to definitions of bachelors and trying to revise them, but that's the kind of process you would go through to try to clarify a concept using necessary and sufficient conditions, and then trying to give counterexamples, trying to add conditions to get rid of those counterexamples, etc. Now, when you go through that kind of process, what you're doing is a kind of conceptual analysis. In this kind of process, in this method, you start with a target concept that you're trying to understand, that you're trying to clarify. Now, maybe that idea is just the idea of a bachelor, or maybe it's the idea of a game, or of something more abstract like knowledge or language or free will. So you have that idea and you want to clarify and make sure you understand it. In order to do so, you start trying to analyze the idea by breaking it down into smaller parts that give necessary and sufficient conditions. So I take that idea of a bachelor, I try to break it down into these smaller ideas of being an adult, unmarried, male human being. By breaking it down into those smaller bits and pieces that give necessary and sufficient conditions, I get a better idea of what's involved in this big idea of a bachelor. How do we discover how to break down these ideas into these smaller parts? Well, there's a number of strategies you can use. You can consider examples and try to find similarities. So you come up with examples of different kinds of games, and then you look to try to see what's common between them all. Now, when you do this, you want to make sure you consider historical examples, contemporary examples, familiar examples, and unfamiliar examples. You want to make sure you get a broad range of examples so you don't leave anything out, so to speak. You might also try to investigate how that concept or idea has developed throughout history. By looking at the history of that concept, it might give you clues as to what components might be necessary, what might be sufficient. You might also try to ask yourself, well, what's the purpose of that concept or idea? And try to think about what the concept would have to include, what would be necessary to include in order for that concept to play that purpose, to achieve that purpose. For instance, imagine a department is trying to decide who the best student in their department is. Well, how you want to define or analyze the idea of the best student might depend upon what the goal or purpose of that concept is. If you're trying to determine who the best student is for the purpose of figuring out who to give a scholarship to, well, that might give you some clue as to how you want to define this idea of best student. Then, once you use all these strategies to try to come up with proposed necessary and sufficient conditions, you then want to try to create counterexamples to challenge your definition, to make sure you're not missing anything or you didn't accidentally include things that you didn't need to, etc. All right, so that's all for this video. See you in the next one. Bye-bye.